Hello guys, today we are going to solve a very short numerical which is quite interesting, and if you look at it, they have given you a special type of a gear we use in machine design, study in machine design. It's called a bevel gear, and they says the spur gear is subjected to two forces caused by contacts with other gears. Okay, so it is subjected for two forces, which are the one force is F1 50 pounds. It is making angles with the z axis and angle with the y-axis. F1 force is unique because it is making, they have given you direction cosines of F1 from x-axis, from the y-axis and the z-axis. So he says calculate the resultant of the two forces, which means he says F1 and F2. He wants the resultant, and we know from the formulation that what is the going to be the resultant? Resultant is nothing but it is Fr is equals to F1 plus F2. And he says another thing which is very important, and he says you have to calculate it as a result as a Cartesian vector, which means these f1 and f2 must be in IJK forms. So we started by taking the first start for x components first. So if we look at this force, 180-pound force, its direction cosine with the x-axis is 60, and since its direction cosine, we can easily calculate that your frx for this f2 force will be 180 into cos of 60. Now let us calculate the all the resultant forces that are being added up into this bevel gear by on the y-axis. So when we go for the y-axis, we know that one of the components of these resultant forces about the y-axis will be for this force 50 pounds. Okay, so if this is 50 pounds, its vertical component, which is parallel to the z-axis, is going to be sorry, for the y-axis it's going to be 7 upon 25, and you can see this axis is parallel to the y-axis, so it's going to be 7 upon 25 and its magnitude is 50. So this is one of the components for fry. If do we see any other components for the y-axis? Yes, this force f2, which is 180 pounds, is also making an angle of 135 degrees with the y-axis, so it is 180 cos 35. Now you simplify it, you get your fry equals to minus 113, which is a scalar quantity. Now frz, for z axis we know what are the components that will be mating. Over here is basically one of the, this resultant force, which is 180 pounds, is making an angle of 60 degrees with the z axis, so it is going to be 180 cos 60. It is going to be this angle 180. The other angle will be this F1 force, which is 50 pound scalar, is making an angle 24 upon 25. So it is 24 upon 25 into 50. But along with this, if you look at it, they have also placed a negative sign. Why? Because this angle, this component of f1 is basically going to be in the downward side. You know why? Because you know this, if you use head to tail, its direction is going to be like this, and like this. We basically, it's going to be uh, just to let you know, it's going, why it is z-axis, because one component is like this, so this is in the other component is like this, so the resultant will be somewhere like this. So you can see this is in the negative z-axis, this is the positive z-axis. So we calculate it and we get it as 42 pounds. Now we want to express these components as a Cartesian vector, so we will write fr, which is equals to f1 plus f2, and along the x-axis we will add all the x, y's and z's, and we get frx equals to 90 I, because it is on the x-axis. The fry will is basically minus 113 j, because it is y, and frz is equals to 42 k. Okay, so it was a short numerical. I hope this numerical will assist you in your preparation for your exam. Thank you.